Okay, you weren't supposed to be able to hear me, but you should be able to hear me now. Please confirm before we begin that you guys can hear me. Stop freaking out, guys. Okay, and YouTube as well, please confirm that you can hear me as well as you can see my screen. Thanks, I will keep that in mind. It's actually on my laptop because of load shedding. Okay, cool. So sorry for being late firstly. I would suggest that you guys free up at least till 12 or 12:05, just in case, because of how these classes are tending to be going. They're taking a bit longer than expected. So yeah. Okay, but let's begin. Assalamu alaikum and good morning to everyone. Welcome back to grade 11 mathematics with inspired teens. Today we'll be continuing from where we left off last week with equations and inequalities, and we're going to try and just speed it up today so we can get as much done as possible. Please remember that if you guys have any questions, you may ask them in the chat, in the Q&A, as well as in the YouTube chat for those of you who are on YouTube. Okay, cool. So let's begin. So, okay, last week, we finished on completing the square. I've actually decided to restructure a little bit for those. So we're talking about maybe doing exponents first. It's fine. We don't really need to do exponents first. We can do exponents next. And then secondly, I just want to start off by going through roots first. We did go through like the numbers, but I just want to go through roots first, and then we can continue completing the square, doing the example that you guys wanted to do with a having a coefficient. We can do 2 examples there, and then we can continue over to inequalities. Then we have inequalities and simultaneous equations, and we're done with this, and we can move on to exponents. So let us try. It's actually good that we because it's not so much. Let us try and finish all of it, right? So firstly, discussing the quadratic formula. I know we did last week to a certain extent, I believe, but let's go through it one more time. So the quadratic formula is a formula that's given in your formula sheet. Okay, and it looks like this. It is x is equal to negative b plus minus square root b squared minus 4 times ac divided by 2a. When we talk about a, b, and c, remember these are from the trinomial, your actual trinomial, right? Your trinomial expression, where a, okay, is the coefficient of x squared, right? B is the coefficient of x, and c is the constant term. So remember, we have ax squared plus bx plus c. Okay, then we have something called the discriminant, which is basically a small part of the quadratic formula, which is b squared minus 4ac. This is important. It is indicated by this little triangle, and we refer to it as the discriminant. Okay, so we'll be referring to it a lot when we are discussing when we're discussing roots. Okay, so things to know: quadratic formula as well as the discriminant. Okay, and it's indicated by that little triangle delta. So now we are going to be talking about the nature of roots. So firstly, nature refers to the type of numbers that roots are. That's English. Then roots, okay, are the x-intercepts, solutions, or zeros of a quadratic equation. Okay, so the roots are basically what makes a quadratic equation, not a quadratic, what makes the trinomial zero. Okay, if we talk about functions, please can you restart? Okay, we didn't discuss much. Okay, if you must, generally, what you should do is maybe catch it up on YouTube, or maybe start watching on YouTube, because YouTube is delayed. That's a good thing to do. Okay, but basically we discussed the quadratic formula. We discussed a, b, c, and it's the coefficient of x squared, x, and then c is the constant term, all respectively. And then we discussed the discriminant. So we didn't discuss much. You didn't miss much. But basically the discriminant is represented by delta, or this triangle, and it is b squared minus 4ac. Right? Then we had is this exponents and surds? No, this is equations and inequalities. Exponents and surds is next. Okay, then we talk about roots. Again, it's basically what makes the trinomial zero. Okay, so when we talk about a parabola, okay, when we talk about a trinomial, we have x squared. Okay, x squared plus 5x minus 3. Whatever equates this to 0, whichever value for x makes this entire thing 0, that is basically referred to as a root. Okay, you'll see we will deal with parabola graphs to understand that. Okay, so now we're going to solely talk about the discriminant, which is b squared minus 4ac. When the discriminant, so basically when you take a trinomial and you put b and you square it and you minus 4 times its a times its c, whatever value you get for that, okay, we have two options. If it is less than 0, there are no real roots, okay? If this b squared minus 4ac is greater than or equal to 0, that means that there are real roots, okay? We will discuss it in terms of the diagram in a bit, right? Then we distinguish between being greater than 0 and being equal to 0. When the b squared minus 4ac is greater than 0, there are two unequal roots, meaning they're not equal in value. One is 5, one is 7. However, when they are equal to 0, when the b squared minus 4ac is equal to 0, that means there are two equal roots. Okay, so both are 5 or whatever it is. All right, then we talk about, we further distinguish when they are greater than 0. If it is a perfect square, they are rational roots. Remember, we discussed what rational is. And when they are not a perfect square, they are irrational roots. Okay, so a basic diagram describing the roots. Okay, cool. Let's move on in terms of diagrams. So let's look at a parabola graph. So remember, trinomial is parabola because the parabola equation is a trinomial, a quadratic equation. Okay, so let's look at the first one. Actually, let's actually start from the right, which is this guy, right? So we're talking about b squared minus 4ac. When it is less than 0, no real roots. So in this case, right, we can see what no real roots look like. So this is when b, where can we write it? B squared minus 4ac is less than 0. B squared minus 4ac is less than 0. So a root is basically an x-intercept, right? That's just what they say here. X-intercept, solutions, or zeros, it makes the 0. Remember, this is y in the equation. Y is equal to a plus bx plus c. This part is y. And if y is 0, that's the x-intercept. So in this case, no real roots would look something like this, where there's no x-intercepts. Then we have one real root. One real root is basically two equal roots, because it's technically one number. Okay, one real root. This is when b squared minus 4ac is equal to 0. And actually, the turning point is on the x-intercept. Okay, so turning point is like technically 2 points. It's on the x-intercept. So therefore, we say two equal roots. Then we have two real roots that actually both are real, two real roots, one real root. But this is two real unequal roots technically. This is when b squared minus 4ac is greater than 0. Okay, no real roots, one real root and two real roots. Or alternatively, one real root could be written as two equal real roots, and two real roots could be two real unequal roots. Okay, so that's roots. We need to have that understanding, especially for functions. They can ask certain questions with regards to it. All right, now let's complete completing the square. So let's just go through the steps one more time. Write in standard form, move c across, divide both sides by a, add b over 2 squared to both sides, factorize the left-hand side of the equation. Alternatively, write a single bracket in the form x plus minus b over 2 squared. Write a single bracket with a square as its power, square root both sides, solve for x. Okay, so yes, for number 5, we can either factorize the left-hand side, or alternatively, we follow this shortcut. X, it's either plus or minus. Again, it's depending what is above it, depending on the question. X plus or minus b over 2, and then we square that bracket. Okay. Cool. Okay, so we're not going to go through our example again. Let's just do our new example, right? Remember, the example we did was without a coefficient of a. Now we're going to do one with a coefficient of a. So we have 3x squared plus 4x minus 15. This is in standard form. Then it says move c across. C is 15. So 3x squared plus 4x is equal to positive 15. Let's talk about the next one. Divide both sides by a. No, it's not b over 2a. I think you're thinking about turning point. This is different. This is completing squares. Okay, in this case, it is 3x squared plus 4x. Okay, we move c over. Now divide both sides by a. I'm going to divide everything by 3. Let's just leave that. We'll just do the math. So x squared, you always want to have your coefficient of a as 1. That's why you're dividing everything by 3. 4 over 3x is equal to 5. Okay, guys, please keep in mind we are not doing trinomial factorization. We are doing something called completing the square. Completing the square has its own separate rules. It's a different method. Okay, we are not doing trinomial factorization. That's why we're not moving everything to the other side. We are following these 8 set of rules. Okay, so if you maybe perhaps weren't here last week, I suggest that if you're a bit stuck here, you need to go back and watch last week's video where we discussed it from the start. Okay, so now we divided everything, both sides by a. Now it says add b over 2 squared to both sides. Okay, so let's do that. I have x squared plus with b, 4 over 3x. Then I need to say b over 2, so I can do it like this, plus 4 over 3 all over 2. Okay, you can utilize your calculator for this. Alternatively, you can use your brain, whichever. And then 5 plus the same thing on both sides. B over 2 squared. Okay, so we've added b over 2 squared to both sides. Let us simplify that plus that. Okay, this gives us, use our calculator, but okay, 4 over 3 gives us 2 over 3, and then we square it, then it's going to give us 4 over 9. Someone can just confirm that for me, please. Then we have 5 plus 4 over 9. So now we need to simplify. It's basically that. So I'm just going to erase this and do the calculation one time. 5 plus 4 over 9. Okay, 49 over 9. I just did that. All you can put on your calculator and you'll get 49 over 9. Okay, so now we've added b over 2 to each side. Now, number 5, the most tricky part. Okay, so factorize the left-hand side of the equation, or alternatively, write a single bracket in the form x plus minus. Okay, we'll show you now how you determine it, whether it's plus or minus, b over 2, and then square that bracket. Okay, so you can either factorize, good luck factorizing this. So let's follow the second one where we're just going to make it x plus minus b over 2 squared, right? We're going to follow that method. So x, remember I said, whatever the first sign is, I'll write it in the rules after this, right? Whatever the first sign is, that's the sign we take. So it's x plus. B over 2 was actually 2 over 3. 4 over 3 over 2 was actually 2 over 3. And then squared, and then you have it equal to 49 over 9. Okay, one more time. I need to write a bracket. You can either factorize the left-hand side as a normal general trinomial, but again, good luck factorizing that. So we're going to follow x plus b over 2, which was 2 over 3. I'm just going to write it somewhere. 4 over 3 over 2 is actually 2 over 3. Okay. And then you square it, equals to 49 over 9. Next step, it says, write a single bracket with the square as its power. That's if you factorize, then you do that. But obviously in this case, we already have a single bracket with the square as its power. Square root both sides and solve for x. So now we are going to square root both sides. Square root this guy and then square root that guy. So this cancels with that. I have x plus 2 over 3 is equal to positive root 49 over 9. Okay, root 49 over 9. You can square root. This is it's an exponent. It's a third rule. Okay, but we will get to exponents. You don't like really need to know it right now. Like, I mean, you should know it by now, but we will revise exponents at a certain time. So you actually square root the top and square root the bottom. Square root 49 is 7. Square root 9 is 3. And we're going to have x plus 2 over 3 is equal to negative 7 over 3, plus minus. Okay, then we can simplify. X is equal to 7 over 3 plus 2 over 3. That is 9 over 3, which is 3, I believe. No, minus, sorry. It's 5 over 3, which is the final answer. Then we have negative 7 over 3 minus, that's negative 9 over 3, which is negative 3. So we've solved for X by completing the square. Okay, I don't understand. Let's see. Let me do the second example and let's see if you understand now. Also, if you didn't watch last week's video, please go and watch last week's video after this so that you clued up, and then rewatch this so that you understand. But I'm going to follow the steps. The first step is to make sure it's in standard form. Done. Then I'm going to take over C. So for X, I'm just going to try and speed through this one, is equal to negative 56. Divide everything by A. That's the next step. So obviously I'm going to have X squared minus, this is 9X, and that is 14, negative 14. The next step is to add B over 2 squared to both sides. X squared minus 9X plus 9 over 2 plus 9 over 2 squared is equal to negative 14 plus 9 over 2 squared. Okay, let's simplify. So X squared minus 9X. This is 81 over 4, and I think that's simplest form. Yeah, plus 81 over 4 is equal to, I'm just going to do this calculation one time. So negative 14 plus 81 over 4, which is 25 over 4. I hope somebody's doing it with me so you can double check the calculations. Okay, and now the next step is to factorize this guy. Alternatively, you could write it as a single bracket in this form, X plus or minus B over 2 squared. So let's take that step by step. Open up my bracket. And I have X, or whatever the variable is. Obviously, if it's not X, then you put whatever that variable is. No, what happened to the X by the 9? So we're not, when we say B, remember B is the coefficient of X. So we just take the 9 because we consider B, which is the coefficient. I think that's maybe what you're asking. And yeah. Okay, then in that case, because the first sign is a negative, we're going to take negative. Then we say B over 2. Now, what is B? B is 9. Okay, I know it's negative 9. Ignore the sign. This here, this negative already solves for all of that. This negative considers all of it. So don't worry about negative 9. Just take 9. 9 over 2, which we can just leave as 9 over 2, or you can write it as 4,5. That's fine. Squared is equal to 25 over 4. Thereafter, I square root both sides. Plus, minus. I made a mistake. That's not a new occurrence. If we keep B over 2 as that, it would be wrong. Yes, you cannot write B over 2 because you have to write whatever B is. You have to write that. Please tell me what my mistake is. Quickly, if possible, if I can. The answer is 64 over 9. I talking about negative 14. Are you sure you took negative 14? Where are you talking about? Okay, I made a mistake in number 2. Can someone confirm this? I don't think there's a mistake. Just explain exactly where, then I can go back and look for that exact mistake. Okay, but let's continue with this. I have X minus 9 over 2 is equal to positive. I can square root 25, square root 4 separately as a numerator and denominator. Positive 5 over 2. X minus 9 over 2 is equal to negative 5 over 2. When I take it over to the other side, I add it. It's 14 over 2, which is 7. X is, I add it, so it's negative 5 plus 9, it's 4 over 2, which is 2. Okay, I think that's correct. There's another method of completing this. There are different variances of it, so if you've learned a different one, that's fine. But yeah. Okay, someone confirmed it, so that's correct. We've still got your thirds. Generally, thirds are done after this. Oh, actually, no, they you might have done thirds before, just because. But I just chose to start with equations because it's more basic than exponents. Okay, that person that was telling me I made a mistake, please specify so that I can correct it. Okay, we went to trinomial factorization. We went through the quadratic formula. Okay. Oops. We went through the quadratic formula. Okay, let us now start with inequalities. What does it become? Negative 5 over 2. Because when you square root both sides, you will get plus minus. You have to insert the plus, positive or negative when you square root both sides. So that's why I have positive 5 over 2 or negative 5 over 2. Square root 25 over 4 is 5 over 2. That's how we got negative 5 over 2. Okay, let's talk about inequalities. Okay, inequalities, right? So at this level, when we learn inequalities, we're not learning like basic inequalities. We have to draw the number line. Okay, we have to show it diagrammatically as well. So inequalities, right? Inequalities. No, that's not true. It's not 64 over 9. That's incorrect. Do the calculation one more time and check your answer. You cannot see the screen, you have to refresh. My screen isn't showing. Okay, I see that it isn't showing. Sorry, let me reshare it. This time it is actually my fault. Do you have to check your answer? Sometimes the value doesn't work. Yes, not in this case specifically. Generally, when you're dealing with denominators, you cannot make the denominator 0 because then it will be undefined. Like in the case of inequalities, then we have to check our answer. Okay, inequalities, positive factors. Okay, so when we talk about inequalities, we talk about these guys, right? Greater than, less than, or even equal to, right? So in this case, greater than or equal to, less than or equal to, right? So when we say positive factors don't affect the inequality, basically we don't have to consider them. Now in the exam, like the examples most likely are not going to be as complicated as something like this, but nevertheless, let's work through it, right? So okay, just give me 1 second, right? I just need to open my notes, just like 1 minute, and we'll be back. Yes, the notes will be on the WhatsApp group. Well, they'll be in a Google Drive link, which is found in the group description in the WhatsApp group. No, your screen is not frozen. Just give me one moment. We'll begin again. Okay, cool. Let's start again. Sorry about that. This was load shedding, and that's like cannot have your notes open because no lights. Okay, let's continue. Okay, so when we're talking about, okay, again, we're talking about inequalities. So we can talk about positive factors. So this statement says positive factors don't affect the inequality. Okay, so it basically means you can ignore them, and I'm going to explain exactly what that means in 1 second. So if we look at what terms we have, for example, x squared, right? X squared is something that will always be positive. So no matter what value for x you substitute, okay, remember, you're going to have to substitute it in brackets. I'm not talking about negative x squared. That's a different story. I'm talking about x squared. X squared is always going to be positive. So I can substitute 500. I can substitute -2. As long as I'm squaring it, it's always going to be positive, right? So that's what we're saying. So something like x squared is always positive or greater than or equal to 0. X squared plus 1, it's something that's always going to be positive because, again, x squared is positive. So 1, if you're adding 1 to it, it's also always going to be positive, right? If we talk about something like x squared minus 1, that's not always positive. What does the line under the sign mean? Good question. So if I just have the sign, this means, okay, let's just say A and B. This means that A is greater than B. Okay. Basically, like if you look at it, I don't know when you remember this from. I remember it from like when I was in grade 1, and they taught me that like this is like the mouth of a crocodile, I guess, like this, like food coming into the mouth, whatever. But that open side is basically the greater than side, and the pointy side is the less than side. Okay, so you could also read this as B is less than A. Okay, if you have that, that's just A is greater than B, right? But if you have A greater than with another line, that means that A is greater than or equal to B. A is greater than or equal to B. That's what it basically means. Okay, cool. So yes, x squared minus 1 is not always positive. Is greater than 0, not always. Not always. Okay, let's just not leave that out. It's not always positive. Not always positive. The reason being is because if x is 0, that becomes 0 minus 1. The answer is -1. Okay. However, something like x squared plus 1, that will always be positive. All right. Then we talk about a to the power of x. Yes, in that case, it's always positive because whatever a is, right? Obviously, provided a is a positive value. So 5 to the power, even if you have 5 to the power -5, that's not a negative. Let's just say -2. That's not a negative answer. It's actually a fraction, 1/25, right? So yes, that kind of term is always positive, as well as square root x, remember, because inside of a surd has to be greater than 0. Why? Because if it's not greater than 0, it is non-real. Okay, so it has to be a real number. So therefore, inside of a surd has to be greater than 0. So whenever we have a square root something, that always has to be greater than 0. The final answer for that has to be greater than 0. Okay, so let's look at this example, right? We have 2 to the power of x times 5 minus x, x squared plus 1, x minus 6. Now, when it comes to inequalities, right? So firstly, if we look at 2 to the power of x, that's something that's always going to be positive. Then we look at x squared plus 1. That is also something that's always going to be positive. So we actually can ignore it completely. We don't have to consider it. Okay. When we look at the remaining factors that are left, we need to find the critical values for this inequality. Critical values. Critical values are basically something that make this 0. That's how you would describe the critical values. So basically, if you have factors, right, you might need to factorize, or if you already have the factors, you equate each factor to 0. So I take 5 minus 6 and I equate it to 0, and I take x minus 6 and I equate it to 0. Factor on top, factor at the bottom. So now in this case, I have x is equal to 5 or x is equal to 6. So now I need to express this on a number line. And then also you need to be able to express it in terms of intervals. So when it comes to the number line, you're going to take your critical values and you are going to input them. So I'm going to put 0. That's a good point to always have. And I'm going to put 5 and 6. Okay. So now we need to determine, okay, basically, once we found our critical values, your final answer is either like greater than the critical values, less than the critical values, between the critical values. So that's what we need to find. We need to find our interval answer. Okay, so our interval answer, we use this. We utilize this guy to try and figure it out. Okay, so what we're going to do is, firstly, we have different sections, okay, on our number line. So the first is before the first critical value, in between the critical values, and after the critical values. We have 3 different sections. Your screen is behind to what you are saying. Sorry, it's a bit delayed. Should catch up. Sometimes it's just an issue with the connection. If it's really bad, just let me know. Okay, so yes, 3 different regions. Before the first one, between them, and after. So we need to determine whether these regions are positive or negative. The way to do that is simple, okay? You're basically going to take a number that is found within that region and substitute it into our equation. So for example, anything before 5 I can take. So you always want to take the easiest number. So for example, I can take 0 or 1, right? I'm going to take 0 because that's easier, right? So because 0 is before 5, I'm going to substitute 0. So I'm going to say 5 minus 0. You can do this directly on your calculator. 0 minus 6. This gives me a negative answer. So that means that everything before 5 is negative. Okay, then I have to take a number between 5 and 6. So that's 5.5 should be the easiest. And I substitute it. So I'm going to say 5 minus 5, divided by 5, minus 6. And this will indeed give me a positive value. So everything between 5 and 6 is a positive value. Then I can substitute something after 6. So I'm going to take 7. 5 minus 7 over 7 minus 6. And that is giving me negative over positive, which is a negative. So this region after 6 is also negative. Okay. Why is your 5 positive? What do you mean? Which 5? Which 5? Are you talking about the critical value? Or are you talking about in between 5 and 6? In between 5 and 6, everything there is positive. Everything here is negative, and everything else here is negative. If it's confusing, I'm going to do another example. And if it's still confusing, I'll try and re-explain this one. But yeah. Okay, so now which region do we choose? Basically, you have to then go back to the question, and whatever this guy is, okay, do they want the values for this inequalities to be less than 0 or greater than 0? They want it less than or equal to 0. So therefore, you're going to choose the negatives because they want it less than or equal to 0. So I'm going to choose the negative regions and explain and write it in terms of intervals. So this red interval is basically saying everything less than 5. So I'm going to say x less than 5. Okay, because the question includes, I am going to include as well, meaning it's going to be less than or equal to 5. I'm going to say x is less than or equal to 5. Then there's 2 red regions, so I need to express this region in terms of intervals. So it's going to be x is greater than or equal to 6. I include because the question includes however, for this specific example, there is one exception that someone asked about earlier. We cannot include 6 because this x minus 6 is within the denominator. So the actual value that makes, because remember I said x minus 6 is equal to 0. I asked which value for x makes this 0, and this is the denominator. And I cannot have the denominator being equal to 0 because that would make this undefined. Okay, so therefore, I would have to exclude 6. 6 is my critical value. I can still use this equated to 0 to calculate my critical value. However, I cannot include 6 because it makes the denominator 0. So this is one of those restrictions. So I remove this. So my final answer is x is less than or equal to 5, or x is greater than 6, not or equal to. Even though the question includes, I will not include. So don't the 5 change to negative and moving on to the other side when you take your 5 to the other side. Okay, I get your guys' question. Let me answer it. Can you show how to do it in the graph? Sure. Yeah, oh, yeah. So basically, if you take 5 over to the other side, it becomes negative x is equal to negative 5. Negatives cancel, you get positive. Okay, let's move over to the next example. Let's do this, right? So these are directly from past papers, these questions. So that one was maybe just a bit of an introduction. Let's look at this one. X squared plus 5x is less than or equal to negative 4. So we want to, firstly, it's an inequality, so we need to factorize. So we bring the 4 over. And now we have a trinomial, so we have it in trinomial form. So now we need to factorize this trinomial. And if you guys remember from trinomial factorization, right, I need how to factorize it. So I need the factors of the first one. Oh, yes. Okay, I'll show that just now. Okay, you can also use a parabola. Yes, that's correct. Okay, x and x, right? Okay, so x and x, right? Okay, factors of the first, then we use factors of the last. So because they're both positive, I'm not going to waste too much time on how I factorize that because we did that last week. So here I have, okay, so technically, right, once you factorize, you want to get rid of the inequality and you want to actually equate it to 0. The reason you want to equate it to 0 is because you always want to find your critical values. Your critical values are what make the equation 0. Okay, so that's why you equate it to 0 and then you solve for x to find those critical values. In this case, x plus 1 is equal to 0. Remember, you equate each factor to 0, or x plus 4 is equal to 0. So x is equal to negative 1, or x is equal to negative 4. Okay, so now I have identified my critical values. Okay, yes, okay, parabola. Okay, parabola I've never really taught. So let me just teach number line. And I'm not sure if it should be sad face or smiley face. So let me go check up on that. And then next week I'll teach for those who do want to learn parabola. Let's hope nobody has a test on this in the week. I'll teach you parabola next week once I confirm certain things that I'm not sure about. Okay, but generally it's a similar concept. Maybe for those who have learned it, understand this way and understand both ways, right? So you change it to 0. Do you not write down critical values? No, you don't have to. You don't have to write critical values before you change it to 0. Okay, so now you've identified your critical values. You can put your critical values on a number line. I have a parabola investigation on Monday. You have a parabola investigation that deals with inequalities, or just parabola as in functions. Okay, so now I write down my critical values, negative 1 and 4. Negative 1 and negative 4. So negative 1 is there, negative 4 is there, and I always just want to know relatively somewhere where 0 is, right? Okay, so I put my critical values down on my number line. Okay, so now is the next step. I need to determine whether they are positive, negative, or positive, negative, right? So I start with the easiest one. So in this region, after, so there's 3, remember, 1, 2, and 3. So after negative 1, I can use 0. I always want to try and use 0. I'm going to substitute it into my trinomial, okay, and see whether I get a positive. You could also substitute it there, I guess. But I'm just going to substitute into my trinomial and see what I get. So I literally, in my calculator, I substitute 0 plus 5 into 0 plus 4. Of course, I'm going to get positive. Okay. And just check each one. It alternates unless there's a square, meaning it's going to be plus, minus, plus, but just double check each one just so that you're certain. Okay. Then we have a number between -1 and -4. I'm going to choose -2. I substitute it into the actual equation and I get a negative as expected. Okay, and then here I should get a positive, but let's double check it. A number before -4 would be -5. And I get a positive, I get +4 when I substitute -5. Yes, your investigation on parabola, is it on parabola with inequalities, or is it just parabola as in functions? Okay, so now I have identified the positive, the negative, and the positive. Now I need to see for my interval answer, which one do I choose, positive, negative, or positive? Because the question actually wants us to find the values of x squared plus 5x plus 4 to be less than 0, I will choose the negative ones, which is this guy, the negative one. So now how do I express this negative interval? Okay, remember it's between the two. Whenever it's between the two, you have the x in the middle and you have two values on either side. So x is either going to be greater than, I'm going to see whether I should include or not. It needs to be greater than -4 or less than -4. I need to include just simply because the question includes. So x is greater than or equal to -4, but less than or equal to -1. I don't follow when you are doing the line. The line is a bit confusing for me. Okay, so do most of you guys do parabola? Or I'm guessing maybe not most, but a few of you guys do parabola. Could you guys just type in chat who does line and who does parabola? Both. Men said both. None. So okay, I see a lot of parabolas. Okay, we haven't reached inequality. I do both, but maybe parabola. None, but I parabola. Okay, both. Okay, so don't stress. Let's not panic, guys. So what I'm going to do is, I've used line because I just find line easier. So I've always taught line. Instead of re-explaining line, because many of you do parabola, right? What I'll do is after this lesson, we do all. Okay, you guys do both. Okay, cool. What I'll do is I'll just release another video. Okay, it will be up. It will be like a very short video, just explaining parabola. Okay, it's very similar. Right, and up until parabola, finding critical values, you should understand that should be the same. Okay, I'll explain that in a bit for the person who asked that question in the Q&A. So I'll just release just a quick video just explaining parabola. Okay, yes, it will be on the YouTube playlist. Where you find this video, you will find that video as well. Yeah, I just needed to clear it because I haven't done parabola in years. I learned it like in grade 9 or whatever, and then I just never used it. I just need to clarify up or down thing, and then I'll release a short video. And do they do things and well, ask you to do both? They won't ask you to do both. They don't even specify. They'll just tell you solve for x. And then the parabola and the line is just a method that allows you to solve for x. Okay, so don't stress. Let's not panic. So let's not continue with inequalities because what I'll do is I'll do parabola because it seems like most of you actually do parabola. Okay, so I'll just release. It's just basically we've learned critical values. Then we just need to utilize this to we'll utilize that to in a parabola form, which is basically similar, but it's almost like you have that as a parabola. Okay, but in this case, yeah, something like that. Okay, where these are positive, and those are negative. Okay, but I will just clarify and then I'll explain to you guys. So probably in that video, I'll explain both. Okay, then whoever has done none or both, or you can choose which one you want to do, which one you understand better. Okay, and I'll re-explain doing the next example as well. Okay, how do you find if it's a positive or negative on number line? I'll explain it in a video later. Okay, is that fine? Everyone's cool, everyone's calm, nobody's panicking. Okay, I would take more time to re-explain number line, but it's no use, okay, because most people do parabola. Again, for those who still do want to do number line, I will explain it in that video as well. Okay, cool. Let's move on to simultaneous equation and let's end on here. Then next week, we will start exponents and surds. Fun stuff. Okay, simultaneous equations. Okay, so simultaneous equations, right? There are also numerous methods, right? Could you guys please type for me in the chat, which methods do you guys use? There's substitution, there's elimination, and there's one more. Okay, isolating is substitution, by the way. Okay, not sure. Okay, substitution. Like 170% of you are saying substitution. Haven't started. Okay. So basically, can we say, okay, I'm going to explain this one thing. Sorry, I forgot about your question, but I'm going to explain it now. The person who asked in the Q&A. Okay, so like I said, I don't see a single one person that doesn't do sub, but I feel like there are some people that do elimination, especially like in physics. People prefer that. You don't. Perfect. You firstly, just like inequalities, they're not going to tell you ever to use a specific type of method to solve simultaneous, especially in grade 11, maybe like in grade 8, okay, or grade 9, whenever you guys did simultaneous. You can use whichever method you like, okay. But I'll be doing substitution. If there is anyone that would like me to do another one, just tell me and then I'll do it. Okay, I'll check your question in a bit. Just for one more thing for this answer, right? Somebody's asking different interval notation. If you are using x is an element of, include -4, include -1. So you can say that as well, right? So remember, with this type of notation, include is a square bracket, and if it's excluded, it's a circle bracket. Okay, that's the only difference. This is the starting term, and this is the end term, right? We will go through this also in detail when we do functions. No problem. No, we don't have to use either. We can say when it's greater than 31, so we'll have OR, meaning, and when it's less, we can allow it. So we don't have to use nominal parameter. Yes, technically we don't. Okay, technically we don't, but I think people just prefer using it because it's a method that makes sense. Okay, so can I get an explanation again? How do we do the signs on the number line? I will explain it. Okay, I'm going to basically just spend some extra time, release an extra short video, just explaining the concept of how to get the signs. I will do number line and I will do parabola. Okay, so that's just to clarify for everyone one more time. Maybe what I'll do is I'll specifically send the link for that video, so you don't have to like use the description to go find it. I will specifically send the link for that video, just to clarify all the confusion that's going on. But for now, let's look at simultaneous equation, and we are going to learn substitution. Okay, when we have another math lesson during the week, we're going to discuss that at the end. Again, please, let's just end at 12, just to be safe. For those who need to leave, you may leave and watch this later on. For those that can stay, please stay. We'll discuss this extra lesson thing at the end of the week, at the end of the lesson. Okay, simultaneous equations. Okay, so when it comes to simultaneous equations, it's two equations with two unknowns. In math, when you have one equation, when you have one unknown, you can solve for that unknown using one equation, one unknown. When you have two unknowns, as in this case, we have y and we have x, and we have x, y, right? We have two different variables. You need two equations to solve for such variables, okay? So in this case, so always in simultaneous equations, right? What you want to do is, with substitution method, you want to isolate a variable, okay? So if you want to, explain it technically, you want to express one variable in terms of another variable, okay? And you always want to choose the easiest variable to substitute. How do you choose the easiest variable to substitute? The variable that is already most isolated, or the variable that has the least attached to it. So for example, let's look at 4y squared. This has a 4 attached to it, and it has a square attached to it. That's a very, very bad variable to leave alone. Let's look at x squared. Okay, that's a little bit less bad. Okay, 2xy. Okay, all of these, for example, on this side are complicated. They have they have a coefficient, they have an exponent. However, let's look on this side. Okay, this one is not so bad. It just has a coefficient. But if we look at x is completely alone. If there is a variable in a question that is completely alone, always leave that one alone. It's always going to be easier. Okay, so let's do that. So firstly, we have our first equation, second equation, and then we're going to rearrange the first equation to formulate our third equation. Okay. Number 3 is going to be us leaving x alone. So in order to leave x alone, I need to take this 3 to the other side. So it becomes 2y minus 3 is equal to x. Right? I'm just going to rewrite it to flip it to the other side. So I'm just going to say x is equal to 2y minus 3. Right? Just so that it looks better. X is equal to 2y minus 3. Okay. This is now my third equation. Okay. We have isolated x, my variable x, and I have expressed x in terms of y. So x can be written as 2y minus 3. Then what I do is, I'll write out some steps for this as well. I need to substitute number 3 into number 2. I need to sub 3 into 2. Always, I label 1, I label 2, I rearrange in 1. Whichever one you're labeling as 1 must be the one where you create 3 from. Okay, let's keep it as that so that it makes sense. So I formed my third equation, which is the rearranged equation, the one where I've isolated my variable x. Okay. I just want to clarify this. So someone's asking, sir, wouldn't 2y become negative seeing that it moved from right to left? I technically didn't do that, right? So what I did was I originally wrote it as this. Right, so you agree with me that this is fine because now I take the 3 to the other side. Okay, now if I have something as x is equal to y, I can write that as y is equal to x, no problem, it doesn't change. So that's technically what I'm doing now, what I did here. Instead of having it as 2y minus 3 is equal to x, I just wrote it as x is equal to 2y minus 3. I just flipped it. Whatever was on the right, I wrote on the left. Whatever was on the left, I wrote on the right. So I didn't like take over a single thing. I took over everything. Okay, so that's why it's not negative. That's why 2y is not negative. I actually took the 3 over and then just wrote x first. Okay, so this is technically the same as 2y minus 3 is equal to x. Okay, I hope that makes sense. So now I'm going to substitute number 3 into number 2. Okay, now in that case, wherever I see x, okay, wherever I see x, I'm going to write 2y minus 3. So there, that's it. Wherever I see x, I'm going to write 2y minus 3. So 2, and whenever you're substituting anything in maths, always use brackets. Always. 2y minus 3 plus 7 is equal to, open brackets, 2y minus 3 squared, because it's x squared, plus 4y squared. You don't have to label. You don't have to label for marks. I'm doing it just so that I can explain it to you and so that it makes sense. And then you can see what I'm doing. Okay, you can label it if you want, just if it makes, like if it's for structure purposes. Okay. So don't you add the y? Don't you add the y to the first part? Yes, correct. Sorry. Thank God I'm not writing grade 11 anymore. Silly mistakes. Okay, what about, yeah, perfect. Thank you guys so much. Okay, so yes, I have substituted wherever I saw x, I now have this guy, 2y minus 3, and then I simplify. Okay, it's going to deal with factorization, but first I need to simplify and then factorize. So here, this is distribution. So this 2y, 2 into 2y minus 3, okay, I can write it actually as 2y into 2y minus 3. It's the same thing, right? It is the, I forget what it's called. It's like the commutative property of multiplication or something. It's basically where the order of multiplication doesn't matter. Okay, I forget the exact name. I think it might be commutative. But it's basically the order of multiplication does not matter. But okay, let's take it step by step. So 2 times, this is now, I'm just going to distribute the 2 in. That becomes 4y minus 6. And I can still multiply it by that y. plus 7 is equal to, I need to square this, or I can FOIL it. Okay, first, outer, inner, last, or I can use the shortcut. All right, remember what is the shortcut? The shortcut is a squared, because it's a binomial squared, I can use the shortcut. A squared plus 2ab plus b squared. Right. So in this case, it's actually going to be minus 2ab, because this is a minus. Okay, so a squared is, okay, let's take it step by step. 2y squared minus 2 into 2y. So a, okay, so this, remember, is my a. This is my b. And then times negative 3. Oh, wait. We already considered for that, so I'm going to put negative there. Then it's plus b squared, which is 4y squared squared. No, what am I doing? 3 squared, sorry. 3 squared. Okay, now we can simplify. So now I can distribute this guy in as well. If it's in the back, it's same like if it was in front. So I'm going to have 4y squared minus 6y plus 7. Again, all these steps, you can skip as many as you can. Okay, I'm just taking it step by step just so that you guys can fully understand. This is going to be 4y squared minus 2 times 2 is 4, that's 12y plus 9. Okay, I multiplied the y now. Okay, now I need to take everything over to one side and solve for y. So actually, 4y, that's going to cancel, because let's take everything to the left-hand side. 4y becomes minus 4y squared minus 6y plus y plus 7 minus 9 is equal to 0. These two cancel because it's like 4 minus 4 basically. 6y plus 12y, that changes to 6y. 7 minus 9, that's minus 2, is equal to 0. I leave the variable alone, take that over, becomes positive 2. I divide both sides by 6. Y is equal to 1 over 3. Must still add the 4y squared. I'm going to cry. Sorry. Thank you. I knew it couldn't have been that easy. Okay, so 4y squared. Okay, now I'm just gonna skip to the simplified version. That's 8. And let's take everything over to that side. So it's 8 minus 4, which is 4y squared. That is negative 12y plus 6y, negative 6y. 9 minus 7, 2. I hope and I pray that's why. Sorry, my brain is just so focused on getting it done. I'm leaving out things. I think you forgot about the last. Okay, thank you. That should be right though. Okay, cool. Now we factorize. Let's see if we can factorize without using quadratic formula. That would be nice. Okay, so the factors of 4, right? I can either choose 2 and 2 or 4 and 4. Sorry, 4 and 1. Okay, and here I have to choose 2 and 1. So I'm going to write these ones first because I have to choose 2 and 1. Also, this is second sign is a plus, so one is going to be, both are going to take the first one, so they're both negative. Now I can decide I need to get negative 6, so it's going to be, yeah, it's just going to be 2 and 2. 2y and 2y. No, I think it's positive 2. It should be positive 2 because I'm taking everything over to the right-hand side. So it becomes 9 minus 7, which is positive 2. Okay, just double check that, someone. Okay, so y is going to be equal. Okay, so let's take it. Let's do 2y minus 2 is equal to 0. 2y minus 1 is equal to 0. So 2y is equal to 2, y is equal to 1. 2y is equal to 1, y is equal to 2. So basically now, if everything is correct, which there can be a chance that the calculations are wrong, but now we've solved for 2 values of y, and that's fine, all right? Don't panic. There's just 2 possible values for y. Because we did trinomial factorization, okay, in certain simultaneous, mainly when you're dealing with squared, because that's the possibility of getting into trinomials, you can get 2 values for one of your variables. So yeah, I got two values for y. So y1 is 1 and y2 is a half. So now, once you've done substituting in number 3 into 2 and you've solved for the one variable, you take that variable and you always sub it back into the rearranged. It's always going to be the quickest, because remember, in the rearranged, because I've solved for y, now I need to solve for x. And in the rearranged, okay, x is alone. Guys, don't say that, man. I still think it's positive. I'm taking over everything to the right-hand side. I'm not taking it over to the left-hand side. I just flipped it. I'm taking everything over to the right-hand side. So when it's 9 minus 7, it becomes plus 2. If it was minus 2, I don't think we would have been able to factorize it. Okay, perfect. Thank you. So we've solved for y. Now we need to solve for x. We have two values for y. So all that means is we're going to solve for two values of x. So I'm going to solve for x1 and I'm going to solve for x2. And all together, I'm going to have two values for x, two values for y. Okay, so when I'm solving for x1, I'm going to use y1. So it's going to be two open brackets. Now I've solved for y, so I can sub it into y. Okay, so it's going to be two open brackets, 1, right, minus 3. And I solve for x1 as minus 1. Let's solve for x2. It's two open brackets. What is my y2? A half minus 3. This is 2 times half is just 1. Minus 3 is minus 2. So I solve for x2 is minus 2. There we go. Okay, so I hope that makes sense. Complicated example, and these are direct from past papers, recent past paper examinations. So they very realistic as to what you're going to be tested. Okay, we can do some simple examples. We'll just maybe continue next week. You guys can practice the ones with squares. Maybe we'll just do this one. It's not as simple, but it doesn't have the square, so it's not as complicated either. Okay, but yes, right, we are getting to the stage where we are dealing with squared variables, and in our simultaneous, we don't just have non-squared variables. Okay, so you need to know how to deal with it, and this is how you do. Generally, it forms a trinomial. You will solve for two variables, okay, and then you can substitute it in and then solve for two of the other variables as well. Okay, I will try to find one that has just an activity sheet or simultaneous, no problem. I'll try to include it in this document. Okay, cool. If there are no questions, no other questions, we can end there. Okay. Okay, actually, no, don't leave. Sorry, before we end, I have the question, right? Okay, so look, we are looking to introduce 2 more lessons for the week, 2 more classes for grade 11. The thing is, so there might be a fee for them, right? Because obviously, like in this time, as you can see, it's like tight to cover everything. So we're looking to do 2 more lessons. Maybe one will be more like orientated towards questions. So we'll do like the syllabus in these, and then the extra lessons to just focus on solving questions. Okay, there might be a fee. It will monthly maybe be around like 150 to 200 Rand. It will be like, I don't know if it's going to be like 2 lessons a week or like 4 lessons a month. We're not so sure. But could you guys let me know actually how many of you would think that you'd be interested in something like that? A month, not per lesson, a month, not per lesson. It's going to be affordable. We are trying to make it as affordable as possible. Okay. Okay, cool. So many of you do seem interested, but yeah, nothing's confirmed. We're just getting your guys' feedback to see if you guys would be interested. which day, which time. One might be like a Saturday afternoon and Sunday afternoon, and one might be like in the week at night. Okay, cool. So we will be in contact with you guys, and anything that any updates that we get, we'll confirm with you guys, and we'll communicate with you guys first. Yes, this class would still remain free, definitely. Okay, cool. 100 will be great. Okay, I'll put it in. I'll put the word in there and let you know. Around that price, it's not like confirmed, but I'm just giving you a gist, or just an estimate, just so that you guys are aware. Nothing is confirmed. We obviously have to sit and do the logistics of it and then get back to you guys. But yeah. Okay, cool. So let's end it there for now. Thank you guys so much for your feedback, and thank you so much for joining the lesson. I will see you guys next week, where we will just do a few examples of simultaneous, move on to exponents. And yeah, we'll probably just end it there next week. And then the following week, we'll start trigonometry. Okay. I think, tell me just before we leave one more time, what are you guys currently busy with? Are you guys busy with exponents? Are you guys busy with equations and inequalities? Or are you guys currently busy with trigonometry? Trig. Okay, it's quite a mix. Okay, so overall, it seems like we are sort of in the middle of everyone, which is really good, right? Rationalizing the denominator by the quadratic equations. Rationalizing the denominator would fall under. Bonus, yeah. Okay, it seems like we're in the middle of everyone, which is really good. It's excellent, actually. We kind of did equations and inequalities. We need to do exponents and surds, and then we'll get to trig eventually. Please don't forget that activity sheet. So, okay, I won't. Thank you for the reminder. Okay, and please feel free to remind me if I forget anything. Okay, cool. Thank you guys so much for joining. Sorry for keeping you guys so long extra. But yeah, I will then see you guys next week. All the best. Good luck with school this week. Jazakallah khair. Thank you so much. Assalamu alaikum and goodbye.